Hey everyone, hope you guys are having a great day today. Today we're taking a look at the next question in our list of studying for front-end engineering questions. This question is called virtual DOM, and let's get right into it. So this is a pretty interesting question. We're asked to take a DOM structure and deserialize it so it could be read in a JSON style format. And we want to eventually serialize it back so it actually looks and mimics a DOM tree structure. So for instance, imagine we have this root div. Inside of it, there's a bunch of different elements like h1 and p tag and so forth, and that they have their own elements. If we were to run our serialization function on this, it will output a JSON structure that would look something like this. So our top root element would be the tag type, the element type, so it would be a type of div. And then it will have a props inside. The props will contain basically two main things. One, the type of child that's inside of it, so a list of children. And the second would be if the div itself or the element has any sort of attributes. So whether that's class name or anything like that, we want to translate that into the props itself so that when we serialize it, we can read those existing attributes and apply them to each individual element. So with that, I want to also mention that this is actually frontendly.com. This is a website that I created. We have over 35 plus JavaScript questions that are asked by top tech companies like Google, Meta, Apple, and so forth. And these questions are all aggregated into this one platform where we showcase the problem statement, the solution with comments, and article style format explaining exactly how to solve each and every problem comprehensively. So if you're currently studying for interviews, I suggest look at frontendly.com. So let's start working on this problem at hand. So I'm going to move my camera here. I've already started the template for this project. So I just copied over that exact root structure here. So again, this root has each one, paragraph, and so forth. And I've already, at the bottom, move this up. I'll make this a little bit bigger so it's easier to read. So I've taken our data structure that we eventually want to output based off of our HTML input. So let's reference first and foremost our HTML element that we're trying to deserialize. So we'll say const element equals to document dot get element by ID. And I believe the root tree is just called root. Yes, it has an ID of root. Perfect. Now let's build our virtual DOM function. So we'll say function virtual DOM, and this takes a root node, and this virtual DOM will this function will eventually output an object which represents our DOM tree, but in a JSON format. So we'll call this const virtual tree equals to an empty object by default, and eventually we'll return this virtual tree. Now let's sort of think about it. The first thing we want to keep in mind and extract is the type of element that we're referencing. So let's reference that. So in the virtual tree, we can just start off by saying that type will be equal to root.tag name. And then this will be all uppercase, so we'll just say to lowercase, just so everything is lowercase. That should be good. Let's also just continuously console.log everything. So just want to make sure we sanity check ourselves in real time. I'm going to clear my console. And yes, for type is div, that's what we would expect. The next thing now is the attributes themselves, such as class name and other properties like that. By the way, if the DOM structure specifies the attribute class, it should be changed to class name. That's just how we're referencing things on the virtual DOM side because class is actually going to conflict with the default class structure in JavaScript. So to avoid that clash, we will just replace class with class name. So let's leave a comment. Let's say check attributes first. So we'll say if root.has attributes. So let's first make sure the root even or the element even has attributes. As long as root has attributes, then what we want to say is for let I equal 0, I is less than root.attributes.length I plus plus. And it might just simplify things to make attributes into a constant variable. So we'll say const attributes equals to root.attributes, and here we can just replace this. So now we can actually go ahead and grab the key value pairs. We'll say const key. So now we can grab the name and value pairs. So we'll say const name equals to attributes I dot name and const value equals to attributes I dot value. Now that we have the name and values, we're going to need to update our props dot attribute name to whatever we've received from the element. So let's try to think about how we can handle this. Let's make sure our virtual tree even has props as a key defined. So we'll say props equals an empty object by default. And then we will create this props object. So we'll say const props equals to an empty object. And here we'll say props, and then let's open and close brackets. And then here we'll say name equals to value. And the reason I sort of made name into its own line is just to handle the case of class names. So what we can do is if the key name equals to class, then we want to return class name instead. Otherwise, we can just return name itself. So this should take care of properties, and we're already running this. So let's just clear this out just so it's fresh, and let's actually define a class name on our root to sort of sanity check this. So it's a class equals to hello world. And now if we take a look at our props, we are actually getting nothing. This is because we never specified props as part of our virtual tree. So we'll say virtual tree dot props equals to props. So now let's run this again. And now we have our ID root and class name, not class, as hello world. So that is working as expected. So I'm going to get rid of hello world because we don't need that for now as our class. But we do actually have a class specified on paragraph. So we do have other references of class in the HTML. So let's clear this out. So now that we've taken care of attributes, we've taken care of the type themselves, now is the tough part. Now we have to take care of the recursive layer, iterating through the internal children and then applying them accordingly to the main virtual tree map. So let's check for children. So how we can do this is we can define a new constant here called const children equals to an empty list. And here, what we want to do is we want to iterate through the root nodes children. So we'll say root.child nodes.for each node. And for each node, we'll do something. But one quick performance improvement we can do here is we'll just say if root.childNode.length, meaning if there are child nodes, only then let's iterate through it. If there's not, there's no reason to iterate through it. So that's one quick check. So the child nodes can contain the tag elements themselves. So for instance, if we are iterating through paragraph, it can contain the buttons, which are tags, and A is also a tag, but the text A and the text from is actually not a tag. This is considered a text element. So one quick way to differentiate between text elements and everything else is we'll say if the node dot tag, what is it called? Yes, it's tag name, because we are already referencing tag name up here. So if there's not a tag name, then this is actually a text node. So we'll say text node is this guy. Otherwise, if there is a tag name, then we know it's a HTML element and we need to do other further things into it. So if it is a tag name, then what we will say is children.push node.tag name. But not just the tag name. The tag name is just going to be the text content. We need to grab the actual text from inside of it. So we'll say tag name.text content. Else, in the else statement, what we're going to do is we're going to say const result equals to, and now we're going to recursively go through our virtual DOM. So we'll copy this and we'll say result equals to virtual DOM. Instead of saying root, what we're going to provide here is the node itself. And here we'll say children.push result. So now that we got the result and we have the nodes from the text content, let's just print out children just to make sure it looks like expected. So now we're getting an error called cannot read properties of undefined text content. Oh yes, I put node.tag name. That is incorrect. It should be node.text content directly. Cool. So we are getting some results. It's a little bit messy. Let's try to clean this up. I'm noticing we're not sort of taking care of like new lines, and there's a bunch of white space here. So let's clean this up slightly so it's easier to read, and also it'll make our results better. So we'll say node.text content equals to node.text content.trim. This will get rid of the white space from the leading to trailing. And then we want to get rid of the new line, so we'll say replace the new line with nothing. So let's run this and print this out. Let's see what we get. In fact, it might be easier to just run it like this. Okay, so now we're getting this is, and then we are still getting a couple of new lines, but that's okay, we'll ignore this for now. One thing I'm seeing is we're also getting these empty strings because of the trim eventually. So let's make sure we are ignoring those empty ones as well. So we'll say here, as long as, and actually we want to bring this inside of our tag name, that is my fault. So in here we want to say, as long as text content is not empty, so as long as it has a length, then we push the node text content. So now, yes, now let's take a look at it. Nothing happened to our props because we haven't applied anything, but it looks like it's not still ignoring the empty lines. So why is it not ignoring the empty lines? Let's ignore that for now. For some reason, these empty strings are still showing up, which they should not be. We'll get back to these empty strings and how we can fix those in a moment. Let's move on to the next portion. The next portion would be to actually apply the children into our virtual tree itself. So we'll just iterate through children. So we'll say if children dot length, as long as there's any sort of length in the children, we'll say if children dot length equals to 1, then we simply want to say children, we want to say props dot children equals to children 0. Otherwise, we want to say props dot children equals to children. The whole reasoning behind this 0 and direct children check is if you look at our expected data structure, if there's children, but the children don't have any siblings and it's the only child, and the child itself is just a string, Like for instance, if we only have a button here and there's nothing else, which is just a string, then we don't want a list. We don't want a list of children. We just want to have that one individual children, which is a type string. So we would have just the button as a type string. However, if it does have siblings, then we will have children with siblings with a type string and the other DOM elements as expected. So let's take a look at our expected output here. Let's see how this is working for now. So we have div, we have our root, we have children. So yes, we will fix this empty string in a moment, but we have our h1. Our h1 is missing props children as well. So there's definitely something wrong in our logic. Let's see what's going on here. So I think the issue is we're saying if there's no length, but we want to check for if there is length. So something like this should fix it. Yes, that seems to fix it. Let me just clear out the console so it's a little bit cleaner to read. So now we have our div, then we have children, which are only 2 children. We're excluding the empty items. Let's look at the h1 props. The props have children called this is, and then the p has a set of props. The class name is paragraph as expected. Then we have children here. So there is an issue here. So the children seems to have a, and then the button itself is actually a tag element, see? So let's try to fix what's going on here. So I think the issue is we should only be doing this text content replacement within our tag name itself condition. So let's fix that. Let's close this out. Let's recheck this now. So our P has props class name. There we go. Now it's working as expected. Children, 0 is A. That's what we would expect. So let's take a look at our expected output. Type is A. Sorry, we have A, children. Then we have type button, which we have here. The button has a props children button, which we have right here. So that's 1. And then we have from, which is here. Then we have type A, which is here. Props href with children .com, and type B, which also has children, which is called front-end lead. So that seems to match here. So type A, props href front-end lead, which we also had here. Yes, href front-end lead. Children also seems to match. So it looks like we have our basic virtual DOM function complete here. So let me just kind of reiterate through what we just did. So first and foremost, we created a virtual tree constant variable. The type inside will just be the root's tag name in lowercase. And then we're defining an empty props. Then we define a props constant. And in here, we're first checking the attributes first. We're checking if the root itself has attributes. If it does, then we iterate through the attributes, and we're setting the name value pairs based off of the attributes from the root element itself. If the name is ever class, then we overwrite that with class name. Otherwise, we keep the name key as is. Next, we check for children. We create an empty children constant variable. We check if the children, if the root has child nodes. If it does, we iterate through it. Then we're checking for node.tag name. That is actually letting us know if that node is a type of text. If it's a type of text, we're replacing the text content of it by removing some of the white spaces and the new lines, so it's a bit cleaner to read. And then we're also checking if the text content has a length, meaning that it's not empty. If it does, we're pushing the children, we're pushing the text content into the children array that we've created up here. Else, let's say this is not a type of text, it's actually a node type, then we're recursively going through a virtual DOM. So we pass the new sub child node back to the very top. This creates its own set of type and props and reiterates through everything what we've just done. Finally pushes it into the children list, which is right here. Then finally, we're checking if the children itself has length. If the length is only 1, then we're actually just directly specifying the props.children is to children 0, which is the first index of the children array. If the length is greater than 1, then we're actually overriding children with the children directly. Finally, we're specifying virtual props dot props equals to our props constant, and we're returning the virtual tree. So this is all working as expected. For now, I'll end it here. There's a part 2 to this question. Part 2 asks us to take our virtual DOM and actually render real DOM with it. So I will leave a link to part 2 somewhere here on the screen above, and you guys can take a look at part 2 when it's posted shortly. If you guys found this video helpful, I would really appreciate if you guys like and subscribe, as it means a lot to me, and check out frontendly.com. Again, it's a very comprehensive list of questions that are generally asked by top tech companies. I personally know the struggle of finding a good and reliable resource that actually has accurate questions asked by top companies. That's exactly why I created frontendly.com. So with that, I hope you guys have a great rest of your day, and I'll see you in the next one. Bye.